Hi, my name is Jason Harlow. Welcome to my V office hour. I'm going to go over my solution for the Physics 132, Test 2, Fall 2009, Question 1, which is based on Knight 2nd edition, Chapter 26, Electric Charges and Forces, in particular Section 26.4 on Coulomb's law. So first, let's carefully read the question. In the diagram below, there are 3 point charges all along the same line, Q1, Q2, and Q3. The distance between Q1 and Q2 is the same as that between Q2 and Q3. Consider the Coulomb force on Q1. Define positive forces towards the right and negative forces towards the left. Of the following 5 combinations of possible electric charges, which will produce the greatest positive Coulomb force on Q1 due to Q2 and Q3. And looking through, you can see that they all have the same magnitude of 1 nanocoulomb, but some are positive and some are negative. Okay, so there's 2 ways of doing this, an intuitive way and then working it out with Coulomb's law. So the intuitive way is this. You've got Q1 over here, and then you've got Q2 and Q3, which are either pulling it towards the right, so it'll have a positive force, or they're pushing it. So if Q2 or Q3 is opposite in charge to Q1, it'll pull it. If it's the same, it'll push it. And you've got 2 of them, so the greatest pulling force, or greatest positive force on Q1 will be when Q2 and Q3 are both opposite charge to Q1. And if you look at all of our choices here, A, one of them's opposite, one of them's the same, there's a plus, minus, and plus. For B, it's the same situation. For C, they're all negative, so they're all repulsive, it's a left force. For D, both Q2 and Q3 are negative and Q1 is positive, so that's going to be the greatest pulling force. And for E, they're all positive, so it'll be pushing. So the answer is D. But that being said, we can go through carefully looking at Coulomb's law to find the forces on these. And so let's take a look at my solutions. Looking at the solutions here, we want to calculate the force on Q1 due to Q2 and Q3. So we're going to use Coulomb's law, and there's 2 parts to it. The force of Q2 on Q1, so Q1 times Q2, and since positive forces are towards the right, if Q1 and Q2 are positive, there will be a repulsive force on Q1 towards the left. So another way of saying that is we put Q1 times Q2, put a minus sign, meaning towards the left, and divided by the distance between them squared. So I'm going to call this 1 unit of distance, so 1 squared. And then same thing for Q3. The only difference here is that the Q3 is twice as far away, so we're going to divide by 2 squared. So it's going to be proportional to negative Q1 times Q2 minus Q1 times Q2 over 4. So all we have to do is compute that for these 5 different combinations and figure out which one is the greatest positive force, so the greatest towards the right. So if Q1 is plus 1 and Q2 is minus 1 and Q3 is plus 1, then we would get 1 minus a quarter, so it's plus 3/4. Now notice I'm not using the nanocoulombs in these, and I'm not using meters for distance. I have some arbitrary unit of distance and some arbitrary charge. I'm just comparing all of these different numbers. So as long as I'm using the same units for distance and the same units for charge for all 5 of these, I should be able to compare my answers. If I look at B, now Q2 is positive and Q3 is negative, so we have negative 1 plus a quarter. That comes out to minus 3/4. If we have now Q1 is negative
and these are both negative, we'll have negative times a negative is a positive, but there's minus signs, so we'll have -1 minus a quarter. So we have -5/4. D, you have Q1 is positive, and these are both negative, so it's 1 plus a quarter. You get 5/4 towards the right. And if Q1 is positive, and these are both positive, positives times positive is positive, and then you put a minus sign, you get, again, -5/4. So the strongest force towards the right on Q1 will be when Q1 is positive and Q2 and Q3 are both negative, both pulling it towards the right. That's the biggest force right there. So the answer is D.
So that's it. It works out either way, the conceptual way or working through the numbers carefully. Basically, opposites attract, sames repel. That's the main message here, and using Coulomb's law. My name is Jason Harlow, and I approve this message.